Audio test, audio test. Audio test. 1 minute and we start. Hello everyone, I hope you can now hear me. This is Ruggero Poletto from CFD Service, and today we're gonna discover all together the new Cloud HPC features about post-processing results directly on the cloud. This is a presentation, okay, of the Cloud HPC website we currently have in place, and this is going to show you about the features and the brand new features of the HPC's product. We are a company that started in Italy in 2018 actually. We do software development in the engineering world, and obviously we provide the Cloud HPC feature, which is a cluster, and we're going to discover the main feature of this particular product during the webinar today. At any time, you can interact with me by simply using the chat available on YouTube. So feel free to make comments, to make any questions you may have during this webinar. And I try to reply to these questions at the best of my possibilities. What is Cloud HPC? Well, it's basically a cluster, a technology which is used to run simulations, engineering simulations, and to do that we use a lot the cloud computing. So it's a new technology which allows users which do not have internal facility to run simulations, to run engineering simulations, to rent these hardware resources for the amount of time that's requested to run their own simulation and to actually get the results. Usually by simulation, I mean CAE simulation, so computerized engineering analysis, which are often highly demanding in terms of hardware resources and for which using normal computers are not enough in order to get to compute the results. So usually you need either to have a massive computer in-house, or you can rely to services like ours in order to rent this computer just for the amount of time you need it, just for the amount of time requested to complete the simulation. Thanks to the Cloud HPC, you can speed up your simulation because you can rent as many hardware resources as you want, and also you can run simulation simultaneously, so run multiple simulations at the same time. Thanks to this, you can focus on product because we obviously provide all the IT support in order to maintain the system fully working at any time, so during the day and during the night, and so you can avoid doing this part of the job. At the same time, you just pay for what you use. You don't pay, there is no fixed cost, you just pay for the amount of CPU hours, so sort of the simulation time that's been requested to you to run your analysis. Uh, since we are an engineering company, we also provide the whole system ready to use, okay? So with all the softwares already installed and all the system is maintained up to date with the most, let's say, topic about security, about the software updates, patches, and so on and so forth. So we just focus on what you really care for you, and we take care of all the IT infrastructure for you. In terms of software which are currently installed at the platform, we have a multiple number of software, and for each of them we have a multiple number of versions. We're gonna quickly have an overview of them. We have Blender, Calculix, and Codestar. In particular, for Codestar, we have 3 or 4 versions installed on the system. Then there is Codestar, CodeSaturn. We have FDS, Fire Dynamic Simulator. We have quite a few versions of that. And we also have OpenFoam, for which we provide support for the 2 main branch, the openfoam.org and the openfoam.com. So the one from the OpenFoam Foundation and the one from the ASI. They are both maintained within the system. Obviously, we have ParaView, which is used to post-process the results, and we also have a partnership with Vento CFD, an Italian company which develops a CFD software particularly used in civil and architecture simulations. Among the main features of the Cloud Hpc, obviously, there is the scalability. In terms of definition, the scalability is the possibility to reduce the computational time for the simulation to get the results by using a high number of hardware resources. This scalability can be intended in 2 different directions. One is horizontal, which means execute several simulation scenarios at the same time, so simultaneously. This allows us to get the results of multiple scenarios with just the same time required to get the results of a single scenario. I'm thinking of running, I don't know, a fan and getting the results of the pressure performed or generated by a fan all at various flows, okay? So you can run various flows simultaneously and get the pressure provided by the fan with just multiple rows, with multiple simulation at the same time. We also have a vertical speed up, which means having the same type of scenario, we want to solve bigger problems. So in general, we want to solve mesh which are more and more big in terms of dimensions, so in terms of total number of elements included in the mesh. In order to achieve this vertical speed up, it is possible to use, let's say, 2 methods in particular: the multi-core, so using OpenMPI, and multi-thread, so using OpenMP parallelizations, okay? Depends on the software, the infrastructure is able to use both of these methodologies. Depending on the software, it is possible to use one or the other or both of them, okay? So that's, since we don't do software development at the moment, we just install what's been provided by the several software houses we have in place. So you can use only the parallelization methods which are available in the software. This vertical speed up is, let's say, limited because one simulation can run up to 224 virtual CPUs. So that's the biggest type of simulation we can run. But you can run several simulations at the same time. So if you have 2 simulations, they can both run on 224 virtual CPUs at the same time. There is no particular limit for the horizontal speed up, so you can run several simulations at the same time, while for the vertical speed up, I repeat, there is this limit of 224 virtual simulation. Given the fact that every time you are executing a new analysis, basically you are allocated a virtual machine where your simulation run, okay, it is possible to get a connection, a direct connection with the virtual machine, and so get an idea of what is actually happening to the virtual machine. We have two different types of connections. So we have a VNC connection, it's a remote desktop, thanks to which you can, from the website, so without exiting the website, you can enter the remote desktop of the instance and have full control of that. So you can run custom command or run the post process directly on the remote desktop. And this is the brand new feature we're gonna discover today all together. Okay, so we can see that in place, and we can see how does that work later on in the three examples I put in place. We also have the possibility to connect via SSH. So the ones of you which are familiar with the terminal, with the Ubuntu terminal or a Linux terminal in general, it is possible to get an SSH connection to the virtual machine while your simulation is running. So directly from the terminal you can log in and edit or modify any files or read all the text files produced by your analysis. Obviously, this requires a little bit of configuration, in particular in terms of the private key, or the public key, sorry. You need to upload into your profile configurations, but once you have done that, you will be able to SSH connect to the instance where the simulation is running. There are many other features which are often very useful to people using the application. It is possible to take let's say, advantage of the API. We have a full set of API which allows an easy integration with your own workflow. Thanks to that, you can execute any operation we are doing manually today using the web application. You can do that, let's say, automatically using this API service. So that can be integrated into Python scripts or Bash or shell scripts, basically. We also have a special integration for Linux. We developed a script named Cloud Hpc exec, which can be installed on Linux, Linux system, Ubuntu and CentOS in particular. And thanks to this, you can command or interact with the HPC directly from your Linux terminal. So once again, this is a feature, let's say, intended for those of you which are quite familiar with Linux terminal. And thanks to this, you can, let's say, avoid opening the website, and you can control everything from the terminal, from launching the simulation, controlling your simulation, and downloading results at the end of the simulation. Finally, we also have a support which is available from 9 to 6 p.m. European time. In particular, we are an Italian-based company, so that refers to the Rome time zone. The support, as you can see, is available through a chat. So from the website, it's just a chat with our support, and at the same time, we help usually our users in order to get the results or to get the best out of the application. In general, using the application, we have a simple workflow thanks to which you need to prepare your simulation offline on your local computer. This is something you need to do before using the application. So you can use any user interface, or you can edit the file manually. That doesn't really matter as long as the files are correctly set up. Once you have completed this phase, all you need to do is upload your case files produced in phase 1 into the HPC platform. Define the process you want to run in terms of CPUs and RAM in particular, and then obviously you need to also to pick the solver. So not just the solver actually, but also the version of the solver you want to use in order to get the results. And then actually the simulation starts running, so you can monitor your analysis at runtime. We have an automatic plot of the convergence and of several parameters for at least for the 3 solvers I mentioned before. But it is also possible to open the remote desktop, as we're going to see later today, and check actually the results produced by the simulation up to that moment. When the simulation finishes, you can download the results and post-process them locally on your local computer. So that's just one click button in order to download. There is a compressed archive which can be downloaded to your computer in order to get all the results produced by the simulation. Or it is also possible to execute what we call a static instance, so an Ubuntu instance, for example. And thanks to that, you can access the results and post-process these results directly on the cloud, so without downloading the results. Keep in mind that the whole system is not intended for file archive, but it's just intended for data exchange. So I always suggest to download the results on your local computer, at least as a backup of your simulations once they are completed. Once also you have completed the post-processing of the results. Today we're going to see three different examples. The first one regards FDS, File Dynamic Simulator. I set up a simple simulation of the stairs with a file here at the bottom. What we're going to see is how you can execute these FDS analysis on the cloud. I have already prepared the FDS file, okay, using a web Blender FDS, so we're using a simple user interface. This file has been already produced, so I just go to that in order to have a look at it, and all together we'll see how I can launch the simulation. So in here I'm opening the folder which contains the FDS file. As you can see, I just opening it. FDS file usually as an input, they just require a text. It's a text file you can open with any text editor you have in mind. Obviously, I'm not entering about the setup of this file, but we just want to see once this file is produced how you can execute the simulation on the cloud. So I'm closing it. I keep the FDS file ready available. So the website, the application, the Cloud Hpc feature is available at the website cloud.cfdfairservice.it. So by entering that, once you have registered, once you are assigned an account, you can actually enter with your user and password, and this is what you're gonna see. So we have the 2 or 3 pages in particular. The first one is the dashboard, which provides a general overview of what is running and of your current consumption of CPU hours over the past month. We have a storage page, which is basically a data exchange between your local computer and the cluster, okay, in order which can be used now to upload the FDS file we just defined so far. So I just press the plus at the bottom, at the top right, and I just drag and drop the FDS file over here. I just press save, and this file will be uploaded onto the cloud. Here you see, you can actually see the FDS file here at the bottom. So once you've done that, in order to execute the simulation, we just have to go under the simulation tab. We press this plus button here, top right. This is a brief, let's say, menu which guides us into the selection of the instance where we want to run the simulation. Currently, we just set up a 4 CPU instance with a standard amount of RAM, so 4 gigabytes of RAM per virtual CPUs. This means that we have 4 virtual CPUs, so the total RAM allocated will be 16 gigabytes of RAM. Under folder, we select the FDS file we just uploaded, and under script, we have all the software which are available to run on the cloud. So we just select FDS 6.7.5. By pressing save, the simulation will be launched automatically by the system. As you can see, we have this new simulation launch. And by pressing the I, you can actually enter in the details of the running a simulation. Usually the simulation doesn't start straight away. It takes 3 to 4 minutes in order for the simulation to start. The first 3 or 4 minutes regards the generation of the virtual machine where your simulation will be run, will be performed, okay? So that is just, let's say, a time required by the system to set up everything for you to launch the simulation. So while we wait these 3 or 4 minutes for the simulation to be completed, I want to move on and see the OpenFoam simulation, how you can launch an OpenFoam simulation. So we'll wait for this, and meanwhile we go to the OpenFoam case. So I go back to the presentation. 1 second is moving on with the slides. So I prepared an OpenFoam simulation, as I said before in the workflow. First, we need to prepare everything in our local computer in advance. So I set up the motorbike case for the OpenFoam. That's quite common to use as a standard case. I also generated for OpenFoam the mesh using SnapPX mesh. I generated that on my local computer, but that can be executed also on the cloud, so we could in theory generate the mesh on the cloud. Everything I'm going to do is using the Cloud Hpc exec script we saw before in order to launch this simulation, in order to execute this simulation using the cloud. Okay, so this is a different method in order to launch the simulation, but it's very common for people who are familiar with the Linux terminal. So I suggest usually OpenFoam is more intended for users which are familiar with Linux. So that's why I want to show you this methodology. So I just enter over here. So I just enter the OpenFoam motorbike example I have in place. As you can see in here, everything is ready for the simulation to run. So I just need to launch the Cloud Hpc exec. That's very easy, okay, because all you need to do is Cloud Hpc exec and press enter, and then you will be guided through a procedure which basically is the same one we saw before in the web application, but this procedure asks us what is the number of virtual CPUs that we intend to use in order to run the simulation. So we want to use 16 virtual CPUs. What is the amount of RAM we want to use? So this time we're going to use again a standard RAM, so 4 GB of memory per virtual CPUs. Then we select the OpenFoam version, as we said before. We have both the OpenFoam from the OpenFoam Foundation, so version OpenFoam 7 and OpenFoam 8, and also the OpenFoam from the AZI group, so 1912, 2006, and 2012. So today we're going to use the OpenFoam version 8, so we just pick that. And then lastly, the last thing is how we are asked to insert is how we want our case to be called once uploaded on the cloud. So we call OpenFoam test case version 1. So automatically will be created a compressed folder which is sent to the web application, and consequently the simulation will be started. Usually it takes, depends on the size of your case, and on the velocity of your network in order to upload the case onto the cloud. Okay, it could take a few minutes, a couple of minutes, in order to upload the case on the system. As you can see now, the simulation has already been launched, and I'm returned, let's say, command to my terminal. So I can move back and to the web application. Now, as you can see, if I refresh this screen, I will also have this new OpenFoam case, which has been launched from the terminal and is running as well. Okay, so by pressing the I can enter in the case, and as before, it takes 3 to 4 minutes now to complete the allocation of the virtual instance before launching actually the OpenFoam solver, which is used to actually execute the simulation. Okay, while these two simulations are running, let's also have a look at the last case, which is Codestar. Codestar is actually a finite element solver, which is used in order to simulate the solids and tension inside of solids. Once again, this solver needs, in order to complete this simulation, we need to define everything on our computer, okay, in terms of the COM file, so the setup of the simulation, and in terms also of the mesh and of the export file, which are the three basic files you need in order to complete a Codestar simulation. Basically, you need to set up everything on your local computer. You can use any version of Salome, for instance, in order to generate these input files. But once they are completed, now we are going to check how you can upload a compressed folder onto the system and how you can launch Codestar as a solver in order to launch a simulation. So how to do that? We go back to the folder where we had the case. Okay, this is the flange inside of which I have all the cases generated. In particular, I have the COM file. I can open it with a text editor just for you to see the setup of the simulation. All right, it's just a standard COM file. I already generated the export file, and I also have the mesh inside here. So everything I need to do is to create a compressed folder. In here I use 7-zip, and I create just this zip folder. All right. Once I have generated this zip file, I just go to the platform. Once again, under the storage, I upload the folder which we just generated. So under add, I press add. I use the drag and drop feature in order to drop the compressed folder, and then I press save in order to upload the folders onto the cloud. That's everything you need to do actually, because the folder will be unpacked from the system once the simulation is launched. Okay, so now that the folder is uploaded, I just go under simulation and I'm gonna launch the FDS, the Codestar analysis on the cloud. This is a small analysis in terms of hardware requirements, so I'll go back to the 4 CPUs with the standard memory. In here, I just select the flange.zip file, which I uploaded, and I just select Codestar 14.4, which is the version of Codestar which can be used for this case to solve. All right, now as you can see, I have all these 3 simulations running at the same time. So as we said before, the horizontal parallelization, horizontal scalability is completely achieved because we are running 3 simulations simultaneously. And we're going to see how you can connect to the instance now in order to see the results of the simulation. As you can see here, we have this button, which is the connect. Actually, in here, there are three or four buttons which allows us to have a full control of the simulation. The first is an eye, which opens, let's say, the details of the analysis. For FDS, we have a log produced by FDS over here, and we have some plots of the devices and of the HRR, which is produced by FDS. So it is very good in order to get an idea of what's happening when the simulation is running. The other buttons allows us to stop the simulation or to sync, to upload the current results on the storage. Now we're going to see the connection, which works by simply pressing the connect. As you can see, I'm still in the browser, and I can actually see the connection. Sorry, this is the incorrect simulation. So I go back, and this is what I want to see, the connection. So the FDS simulation, which is currently running. As you can see, I'm still in the browser, and actually from the browser, I'm connecting to the remote desktop of the instance where the simulation is actually running. In here, I have everything I need in order to actually see the results of the simulation. In particular, I can double click on Smoke View, and automatically Smoke View will open for me to see the results of the simulation. So this is the actually running simulation. So I see what's actually happening on FDS right now, right at this time. Okay, and in here I can actually show you the smoke view. So through smoke view, I can show you the smoke, or I can turn on also the heat release rate. so I can actually see the flames of the fire, which is here at the bottom. Obviously, if I set up previously in the FDS file, I can also have a look at the velocity magnitude in a slice, for example. Okay, in here I just put a slice and that's it. Okay, so everything is ready here for you to post-process the analysis at runtime and while the simulation is running. And using the menu here on the left hand side, you can maximize the screen to, let's say, fill all your desktop and to have actually the feeling that basically you are using the instance as your local computer. Basically, at this moment, it is also important the velocity connection you have available. You don't need a massive connection. Usually an ADSL connection is enough for you to have access to this capability. And also, as we said before, it is possible at any time to connect to the chat support here on the left hand side and have an help in case anything doesn't work or in case we want, and I don't know, to solve some part of the problems we are having with the platform. Okay, so this in terms of smoke view, this works runtime and you can have a look at what's happening on runtime. Obviously the same also happens for ParaView, which is the default post-process software used for OpenFoam. So all I need to do is enter the OpenFoam cases, which is currently running. Just wait a little bit for the system to connect. Once again, we are connected to the system. As you can see, I'm looking to a remote desktop. This time I'm not opening Smoke View, but I open ParaView. So I double click on ParaView. It will take a few seconds, but ParaView is gonna open. And once here it is. Once I have ParaView opening, I just open the post-process file, the system.form file I have already prepared. Since this simulation is still running, I just need to open the composed file and probably go to the last time step. So now that I press apply, I can repeat, I'm having a look at the results of the running simulation. So this is not something I prepared in advance, okay, but I'm just having a look at the results of the simulation which is currently running. So let's have a look. Probably no results have been produced yet. So I avoid skipping the zero folder. Here it is. So I just, this works like normal ParaView, so I can at any time create slices, I can see what's happening inside of the system, I can actually have a look at the pressure, I can modify the scale, I can zoom in to the motor, to the motorbike, and probably I can also color using the velocity of the motorbike in order to have a closer idea of the flow close to the motorbike, and obviously I can run the kinetic energy, the turbulence kinetic energy, in order to get a better idea of the flow. As I said before, these we are actually seeing the results of the running simulation. So if I just refresh and if the simulation performs some more, I can go to the latest time step I have in place, which is 1800s, and get an idea of the simulation results at a more advanced time step. Okay, so as we see now, everything is live. As we saw before, I can maximize the window in order to have a full screen option, and I can here at the bottom also have access to the terminal for me to insert any custom command to OpenFoam. I don't know if I want to modify some boundary conditions or have a look at the log files produced by OpenFoam. I can also have access to them using the terminal available here in the application. So that's quite direct to use, in particular if you are familiar with the Linux system. That's quite easy to use a system in order to get control of your running simulation. And last but not least, we're going to see CodeAster, which actually was a shorter simulation. So the whole simulation has already come to an end. So in order to see the results of a simulation which is completed, we can allocate what we call a static instance. So once again, we select the hardware we want for that instance to have. We select the CodeAster folder, which is this flange.-ca136, which is being uncompressed, considering the previous analysis. And this time, instead of launching CodeAster, we are going to launch the Ubuntu instance. Okay, so Ubuntu 20.04 in particular for CodeAster. In this case, we're going to start, let's say, a new static instance, which is an instance which is not supposed to run a simulation. It's just an instance which we can access using VNC or using SSH methodologies in order to post-process the results of our analysis. As we said before, it will take 3 to 4 minutes in order to start this instance. Okay, so I already started this before. And we are going to have access that, right, in order to speed up a little bit the presentation we are doing right now. I see there are no questions so far, so I hope everything is clear, but for anything you might need, feel free to interact with me using the chat. So I'm entering the issue I allocated before. 1 second, there it is. I'm connecting. Once again, we are using the remote desktop. Okay. In here, it is possible to execute Salome. There is a shortcut in here to be executed on the desktop. This will allow me to open Salome. Obviously, I need to enter into the Paravis submodule. Using the Paravis works pretty much like Paraview. So I just need to open the Codestar results, open the RMAD file produced by Codestar. I just press apply to open it, and these are the results which I can see. I just go to the last time step, and I can color everything in order to see my results. In particular, in here I can see the von Mises stress in order to get an idea where I get the highest stresses on von Mises. But I can use also von Mises with sign in order to get an idea of the places where I have positive stress or negative stress, so where I have a compression state or a tension, an expansion state of tension. Okay. Once again, everything can be expanded in order to have a full screen, let's say, post-process, so to have a full control of everything that's happening on this machine, and you have full control, so you can save results, you can save images, and download them into your local computer in order to, I don't know, create a presentation or create a final report. So as you can see, everything is quite fluid, it's quite smooth, also the visualization. So I suggest you to test this particular new feature, the remote desktop, because it's a brand new thing which has been requested by a lot of users and helps a lot in order to get an idea of what's happening at your simulation at runtime. So while the simulation is still running on the system. So you can have full control, and in case you can stop the simulation if you see the results are not going properly, or you can, once the simulation has been completed, you can post-process the results, and we saw right now for Codestar. We can actually try also to open the other instance of Codestar we created before. Let's see if everything is allocated. Probably still a little bit early, but it will take a few seconds, but the desktop will appear here at the bottom once the system is completely set up. Okay, let's do this. Let's move on with the presentation. I have a couple of more slides, very easy to see, and then I'll be completed. Beyond the solver, yes, as we saw so far, it is possible to run OpenFoam, CodeStar, and FDS, but many other solvers. It is also possible to run customized script, okay? So all your Bash or Python script can be executed on the web application. There is a particular features available on the cloud, So you can do that. You just need to make sure you have configured with the IT system of the application in terms of the folders. But since we are using for OpenFoam the default installation provided by the OpenFoam Foundation or the ASI group, so I guess it's quite easy for you to create your own script and to run your own script on the cloud. In terms of prices, the price scheme is quite simple. It's just based on the virtual CPUs used. Okay, so on the total amount, let's say, of run simulation, run every month run simulation. The price varies a little bit depending on the RAM allocated per CPUs, and it varies from 8 euro cent per the smallest amount of RAM to 12 euro cent for the biggest amount of RAM. And this price is the virtual CPU hour price. On top of this, it is possible to get a massive discount, a 50% discount, if you use what we call the pre-instances. It's a particular type of instance which allows us to get this 50% discount, but it is not available for all the software installed on the platform. Currently, it is available just for OpenFoam, any version of OpenFoam, or FDS, any version of FDS. Okay. In order to access this instance type, usually we create a small training using a remote desktop, which let's say tells you, which aims at giving you the information about the positive and negative advantages of this instance type. Okay, so that's by default is not activated for everybody. In order to get that activated, you just need to get in contact with our support system and get an idea on and organize this tutorial with our support system. The last bit regards the registration. In order to register to the web application, you just need to go to our reference website, which is cloudhpc.cloud. Okay, in this website you can get all the informations about software, about the costs, about pricing. And if you see, we have quite a good trade at the moment. If you press in here on the register to get 300 free CPU hours, you are redirected to our registration form. In here you can register and get 300 free CPU hours for you to test the application before actually entering, let's say, the most advanced features of the application. In the basic account you're going to open using the free account, you won't get the whole features we saw today, but you still get you can get an idea on how the simulation, on how the application works, and then you can get everything else. All the features which are not included in the basic account, in the free account, will be included once you move to a more advanced account and pass into a paying users. With this is everything for me for the presentation. In here you get all the contacts for me to get in contact with me and with the company. For general, let's say, questions, you can email the company info@cfdfairservice.it. For HPC related questions, you can email directly the HPC department at info@cloudhpc.cloud. And obviously, as we have just said, you can register or get more information on the application on the dedicated website at cloudhpc.cloud. So far I haven't received any question in the chat, so I'll just wait a couple of minutes for for the last remaining questions to arrive or to be made. But if you don't have anything else in particular to ask, I'll be thanking you for participating to this webinar. Obviously, I invite you all to take advantage of the free credit of the web application, so to register and to start using the web application. Also in consideration of the brand new release of the remote desktop and of the possibility to get results, to get a post-processing of your results directly on the cloud. No questions are coming yet, so I consider this webinar coming to an end. I thank you all for participating, and I invite you to keep an eye on the updates on LinkedIn, on our socials, and on YouTube in particular. That's everything from my side. Thanks again, and bye, and see you soon on the Cloud HPC.